Our last example today is going to be to solve the equation, third equation, 3x equals 12. So, step one, with my page already creased to separate my work from my explanations. One easy way to think of this. This would be where you're writing an essay, and this would be where you're making bullet notes to yourself about the kinds of points you want to be sure you covered. Or think of this as going through a recipe, and this is where you're marking off the specific ingredients and where they can be found in the kitchen. Or this is where you're making part of an argument, and this is how you know that part of the argument is true. It's effectively what we're doing here. So, I'm going to write down my problem. 3x is equal to 12. That's my initial problem. Now the picture is going to look a little different because instead of having one box to represent x, I have 3 boxes. So when I draw my balance, the left side of the scale has 3 boxes in it. The right side of the scale has positive 12, so it has 12 plus signs in it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. There. Now I've shown that in this particular case, 3 boxes of unknown quantity are going to balance out with 12 items. The question now is, how much is in each of those boxes, assuming each box has the same amount in it? And that's what this problem is ultimately asking us to solve. Now, let's get on with the process. Now, when it comes to undoing multiplication, moving that 3 to the other side of the equal sign, as some will say, or simply trying to isolate the x, many different forms of discussing what we're doing here. It's a little different writing, so I'm going to rewrite that so I have a little more room to work. 3x is equal to 12. And the opposite of multiplication would be division. So I'm going to write that I'm going to divide each side by 3. So in other words, if I think about my scale, since I know that 3 boxes is 12, if I divide this by 3, I'll only have 1 box left. So I limit myself to 1/3 of what's there. That means I have to limit myself to 1/3 of what's here to maintain my balance. So when I write my steps, I'm going to be writing down that I'm going to divide both sides by 3. Now I can go ahead and complete my work. The 3's cancel, leaving me x on that side. 12 divided by 3 is 4. So my answer is that x must be 4. Finally, I want to check that. And as part of my check, I'm going to plug that back in. Is 3 times 4 equal to 12? Is that a true statement? Is 12 equal to 12? Yes, it is. My answer checks out. And now what I'm going to write over here is that when 4 is substituted for x, the equation 3x equals 12 is true. And then I'm done. Again, the important thing in this statement, when 4 is substituted for x, 3x equals 12 is true, is I'm stating what I'm getting as a result when I actually complete my check, which is a verification that x actually did equal 4. All right, have these ready for us when you come in next time? Next class, we're going to sit down, we're going to start looking at these problems ourselves and work our way through a small handful.